All right, welcome back. And so here we have what was in step two, right? Our final answer from step two, all over h. And what you see is we can factor an h out in the numerator. We'll be left with 8 minus 4x minus 2h all over h. And then we have h over h, which will become a 1. And so our final answer here is 8 minus 4x minus 2h. And the final step is to bring in the limit. All right, so now we have to find the limit as h approaches 0 of our difference quotient. And this will just equal the limit as h approaches 0 of our final answer in part 3, which is 8 minus 4h. I'm sorry, 4x. Thank you. I know someone corrected me. Minus 2h. And when h is 0, this term here will go to 0, correct? And so our final answer is 8 minus 4x. So f prime of x, so the derivative of our original function, is 8 minus 4x. Okay. So notice in the last example, the original function was 8x minus 2x squared. And again, you might want to pause the video and write this down and then come back. And we found that the derivative of that function was 8 minus or is 8 minus 4x. Remember that derivatives represent slopes of our tangent line, right? So what this tells us, this derivative here tells us, is that the slope of a line tangent to the graph f at any point, because remember, f is not a line, f of x, that's a quadratic, right? Any nonlinear graph function, the slopes will change at various points on that graph, right? It's not constant like on a line where the slope is a constant number. And so this derivative is the slope of the tangent line. So if I ask you all in part A here to find the slope of the graph of f at x equals 0, 1/2, 1, 2, and 3, then all you need to do is plug those values in for our derivative function, which is 8 minus 4x. So go ahead and pause the video and do that. All right, so you should have received these values. F prime of 0 is 8, F prime of 1/2 is 6, F prime of 1 is 4, F prime of 2 is 0, and F prime of 3 is -4. So that means at those points on the function on f of x equals 8x minus 2x squared, if you looked at the tangent line, then the slopes of those tangent lines are represented here. Okay, so part B, graph the function f of x, our original function we just dealt with, 8x minus 2x squared, and use the slopes found in part A to sketch the lines tangent to the graph at x equals 1/2, 2, and 3. So recall from the part A, f prime of 1/2 it was 6, f prime of 2 0, f prime of 3 is -4. So let's look at their graphs and look at the tangent lines at those values. Okay, so in this function here, we see we have our values, and I already, thanks to Desmos, I took a snapshot of the graph from Desmos, and I want to show you, and unfortunately, the platform I'm on, my lines aren't as straight as they need to be, but hopefully you get the gist of what this is representing. So here, 2 is probably the easiest one to see. So you see at 2, the point here is a parabola, upside down parabola, right? It's really at the vertex. So when the slope is 0, remember that means a horizontal line. I'm going over 4 minutes. I'm almost done with this. It's a horizontal line. Here at 3, if you found the slope of that tangent line, it's going to be -4. And here it's a little bit more steeper, so it's 6. Okay, I'm stopping this video, and I'll see you in the next one. Oh, you'll hear me in the next one.